Okay, let's solve this number here, which is saying a truck is found to travel with a uniform speed down a slope which falls 1 in 112. If the truck starts from the bottom of the slope with a speed of 18 kilometers per hour, how far will the truck travel before coming to rest? And now here is our solution. We are going to see how we can solve this kind of problem. First of all, you should remember that it is a slope. Okay? So a slope which is having some gradient, and if it's having a gradient which is 1 in 112, it is implying that I'm going to be looking at if I have a slope that I have a rise of 1 meter, that is corresponding to for every rise of 1 meter, the slope the other side goes by this value here, that is 112 meters. And if you look at that, if this angle is theta, we can basically say sine theta equaling to 1 out of 112. That is what actually this can mean, that sine of theta will be 1 out of 2. That is opposite hypotenuse, rise on a fall or length along the slope. And then also another important thing is that if the truck starts from the bottom of the slope with a speed of 18, so there are two cases here, if I can tell you. For case one, we can say case one, the truck is traveling down the slope. Say traveling down the slope. What is very true there, I can make simple sketch here, and then I can say, before I make a sketch, let me let some values I will be using. I can say let R1 be the resistance, the motion, and then I will use R as normal, reaction, and then I will decide to use P as the driving force, the force exerted by the engine. And then now if I'm looking at this case, I'll say if the slope is here theta, we have already agreed that sine theta equaling to 1 out of 112, isn't it? And then I can say I have a truck here, that just some simple sketch, and then I say this is my R1. Resisting force always in the opposite direction. This truck is moving down the slope by driving force P. It has a component of the weight of mg sine theta, and I can also say let m be the mass of the car. I can also add there, so that I have here mg sine theta, which is 1 out of 112. Okay? Something like that. I can only draw relevant forces. And I said it was moving with uniform speed. So I can say, using my equation, because our interest is in this equation here, equaling to MA, and this one is the same as force in the direction of motion minus force opposing motion. So force in the direction of motion is P plus mg times 1 out of 112, okay, minus force opposing motion is R1, should be equaling to m times 0, okay, since acceleration is 0. Why is acceleration 0? Because we are saying that we are looking at uniform speed. It was traveling down at a uniform speed. And then R1 can be equal to P plus mg times 112. Okay? And now I can go to case 2 when moving up the slope. Moving up the slope. If now we are moving up the slope, I can maybe try to make some other simple sketch here. Theta, this car now is moving up the slope. The resisting force now will be here, R1, and I will have this one here as the mg times 1 out of 112, and I'll have here my driving force P. Okay? And now because it's moving up, okay, and now this one here it was moving down, so they're saying that how far uphill will it travel before it comes to rest. So let's look at what we are calling the driving, our value of resist, of acceleration, I mean. So we can say also using Fr equaling to MA, and then force, the direction of motion is P, and then minus mg times 112, okay, and then minus, I can say plus R1 is equaling to MA, okay. That is what we can now look at, and then I can say P minus mg times 1 out of 112. If you open it, it will also be a minus, okay, minus R1 equaling to MA, and then I can say P minus mg times 112 minus R. What is my R? My R is this value here. My R is this value here. So I can say minus P and then minus mg. Or if you're getting confused, I can just say P plus mg times 1 out of 1 equaling to MA. And then my P will be minus C. You can see what happens here. This and this value here. We can say, if I bring that, I can say, how far will it travel if the track starts from the bottom of the slope with the speed of that? How far uphill will it travel before it comes to rest? So that means that we are looking at the car beginning from the bottom and then comes to rest. So why is it coming to rest? That means that we are having no driving force. It is moving against resistance, and that is why we are having, that is why it is coming to rest. So that means that P will be equaling to 0 in that case. Because we are saying that the car will start traveling here but it's going to come to rest. Therefore it means here P will be equaling to, will be taken to be 0, because there will be no force in the direction of motion, and that is why the car is going to come to rest. If the driving force was there, it was not going to come to rest. So therefore we are going to say P equaling to 0, and then I will say now I'm having minus mg times 1 out of 112 minus mg times 1 out of 112 equaling to MA. And this one you'll get it as 2 mg out of that, but this one can first excuse us with this, and then this one will give me A as negative g out of 56 meters per second, and that is our acceleration. And then to get how far upstream, we can now use the third equation of motion. I can now say, let me see right here, using v squared equaling to u squared plus 2as. So if this body comes to rest, what is very true, the final velocity will be 0. but they have given us that it was traveling with a speed of 18 kilometers per hour. You can as well change it into meters per second. So initial speed of 18 kilometers per hour is the same as 18 times 1,000 over 3,000. That this and that will go. So we shall have 180 divided by 36. That will basically give us 15. Let's first confirm and say 180 divided by 36. That is 5, That is 5. So that means that this is equaling to 5 meters per second. So I can now substitute here and say 0 is equaling to 5 squared plus 2 into my acceleration. My acceleration is negative 9.8 out of 56 s. So what is my s from here? Is what we are interested in. So my s is supposed to be, let's say, 9.8 times 2, then divide by 56. I'm getting that, and then 25 divided by the answer. That is 71.4 to something. So it is 71.42857, something like that, meters. So the distance moved upstream. The distance moved uphill before coming to rest is basically this. Okay? And please take note about this, that in this case here, when they say if the truck starts from the bottom of the slope with the speed of that, how far uphill will it travel before it comes to rest? Look at it coming to rest. If it is coming to rest, that means that the body will never come to rest if we are not having a driving force. So basically we take the driving force to be equal to 0 if at all it is coming to rest. So it will be moving on against the resistance. So let's meet in the next shift.